Happy 4th of July, everyone. Now, if you hear any sound effects in the back, it's probably celebratory music or some really excited, intoxicated neighbors. All right, so let's delve into the session. Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Exponential Function Basics. Concept number 1, parts of an exponential function. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. What we're doing here is effective. I'm coaching you to turn your wants and desires of getting an A or perfect test scores into a new paradigm. I want to include everyone who needs a boost in Algebra 2. And if I could stick every single math student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I probably would. So inbox me at memedicine@gmail.com to get your healthy dose of Algebra 2 by purchasing the complete cram session beyond the exponential function basics, okay? You have lots of peers, classmates, friends, and or colleagues who are taking Algebra 2 with you, and they could benefit from this cram session as well. So be sure to spread the word and tell them to inbox me at memedicine@gmail.com so that they too can purchase the complete cram session. You'll be glad you shared because they'll make great study buddies. And last but not least, the concept of cramming often gets a bad rap. But what people are thinking of is hurrying, which is a result of fear and can consequently be destructive to your overall learning process. We're not hurrying here, we're cramming, and there's a huge difference. Hurrying is jam-packing tons and tons of unorganized information into your mental spiritual DNA over a tiny amount of elapsed time, whereas cramming is taking quantum leaps in your understanding in an organized way in what seems to have been an instant. All right, so let's delve into concept number 1, parts of an exponential function. Exponential function. What is the general format for an exponential function? Definitely press pause if you need to, and I'll give you a moment to think. All right, so hopefully by now you are able to press pause and come up with an answer, and if not, that's completely fine. Let's tackle this riddle together. Okay, the equation y equals b to the x, where b is the constant, x is the exponent, and y is the power. Now, the result of an exponential function is called the power. Oftentimes, people do a swap and they call the exponent up the power, but that's actually a misnomer. Let's say this exponent were 2. Okay, so y would be the second power of the base b, right? Okay, yeah, okay. So again, y equals b to the x, where b is basically the constant, x is the exponent, and y is the power. And this is what an exponential function would look like on a Cartesian coordinate plane, okay? The y-intercept is 1, because we know that 0, any base raised to the 0 power is going to yield 1. And so this is what you get with a horizontal asymptote here and a vertical asymptote of sorts. Well, it's growing up about here, okay? Alrighty then. Let's delve into this a little bit further because we have some cans and cannots. Okay, the first cannot is has to be positive, okay? So negative b is not allowed. And let's say, for instance, that you were to insert a negative constant. Let's see what would happen. Let's say this negative constant is 2, okay? And since the exponent x can be any number, let's say we do 2 raised to the 1/2 power. Well, we know that when we raise a base to a fractional exponent, you're going to raise the base to the numerator. So 2 to the first power is just going to be 2. And then whatever the denominator is, you're going to take the nth root of the denominator. So what this turns into is negative 2 to the first power, the square root, or the second root. Okay? And if you know anything about imaginary numbers, you know that this will be broken down into the square root of negative 1 times the square root of 2. Okay, and what will happen is we're going to yield the square root of negative 2i, because this radical negative 1 is an imaginary expression that we call I. It's not real. So this was a very interesting number because it has two interesting concepts going on. First, its imaginary aspect and its irrational aspect. An irrational number is a number that can't be expressed in fractional form. Okay, you could express the square root of 1 over 1, but you could not express the square root of 2 over 1, simply because, let's say you try to evaluate the square root of 2, you're going to get something that equals 1.4, I think 3, and then the decimal continues on and on forever. It never terminates. So that's why it's irrational, because the numerator is like a never-ending decimal. Okay, so yeah, that's exactly why we don't want b to be a negative base, because things like this can happen. Okay, alrighty then. And the second cannot is that b cannot be equal to 1. Why? Because you're going to yield a constant function. If you were to raise 1 to any power, all right, all the way up to infinity, 1 times 1 times 1 times 1 times 1 is just going to be 1. So that's problematic. And what you get is a flat line or a constant function. So we don't want that, okay? So yeah, the base can't be equal to 1 for some reason, because of the flat line issue. Alrighty then. I think that's pretty much it. And as you can see, intellectual comprehension of this material was not difficult at all. And after the short amount of time it takes to complete the entire Cram session, you'll be prepared to answer a battery of questions about any Algebra 2 concept. So inbox me at nemedicine@gmail.com to order this complete Cram session. All right, so ask your grandmother, ask your parents, ask your friends, boyfriends, girlfriends to help you cram. It's well worth it. You'll tap into your imagination and you'll just feel uber better about yourself, because let's face it, Algebra 2 is hard. It's not easy. Don't let anyone fool you. All right.